Let's talk about domain of the rational function. Rational function means you will have the polynomial on your numerator and denominator, okay? So, well, let's talk about the common mistake about the domain of the rational function, okay? So sometimes like basically like, like the x value which make the denominator equal zero will be out of domain. So we have to exclude like, those kind of, um, like those x value like from the like domain, okay? And but the thing is like whenever you have like same factor on your numerator, you will cancel out and you just remove from the like the exception of the domain, okay? It is big trouble, okay? So like what I will tell you is whenever you have to find the domain, do not cancel out anything, okay? That cancel out part is also out of domain. We're going to talk about this one in next problem. That is a whole. Is it okay? So like let's do this, okay? Look at the first one. It is very simple thing, okay? So we know x equal to -4 will make the denominator equal 0, okay? It is out of domain. So your domain is all real number except -4. But what about the interval rotation? That is easy. Whenever you confuse about the interval rotation, please use the number line, okay? That is the easiest way, okay? On a number line, so we know x cannot be equal to -4. So on the number line, this point is not yours, but this part and this part is yours, okay? So interval rotation, we can say the left wing is from -infinity to -4 is not inclusive and -4 to infinity, okay? So like I believe you learned it with the like the U notation, which is the union. But like mathematically you don't have to write the union notation, just come out with fine, okay? So I would like to write like this way. That'll be fine, okay? So what about B? Same thing. We're going to do the factoring for your denominator, okay? You don't have to worry about numerator to finding the domain of this, okay? So the denominator is, which means x cannot be equal to 3 and -3, right? So as I told you, using the number line is the best way for interval notation, okay? Or easiest way. So we have to exclude this 2 point, okay? Then now we have like three sections, right? So first section from -infinite to -3, and the center part, and that is the interval rotation of the domain of like problem B, okay? What about C? We will do same thing, okay? Do the factoring for your denominator, okay? So, where again, to find the domain, you don't have to worry about numerator, okay? It is x plus 1 and x minus 3. Then I can say your x cannot be equal to -1 and 3. So on a number line for the interval rotation, okay? -1 and 3, these 2 points are not your domain. So we have like three sections for this problem as well. So interval rotation is what? -infinity to -1, 1 to 3, and 3 to infinite. Is that okay? And D is what's so nice problem. Okay, but keep that in mind. Even you are really tempting to cancel out x plus 1 factor and x plus 2 factor. Don't do that. If you cancel out, then you're going to assume that it is 1 over x plus 3. Then like your domain is all real number except -3. No, 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 no. It's dangerous, okay? Like we will discuss with this one later. X equal to -1 and x equal to -2 is the wholes, okay? And x equal to -3 is the vertical asymptote, okay? So anyway, domain is like we have to like exclude all those 3 points, okay? So we know x cannot be equal to -1, -2, and -3. So on number line, exclude. So we have like four separate sections. Okay, in an interval rotation, -infinity to -3, -3 to -2, -2 to 1, and -1 to infinite. It's okay. So what about E? So as I told you, you don't have to worry about your numerator, okay? We are not going to do factoring for your numerator for this problem, okay? Because the problem asks you to find domain of your rational function, okay? But we're going to do the denominator factor, okay? So first step is we're going to pull out the common factor of your denominator, which is 2. And then factoring. It works with x minus 3 and x plus 4, right? So we found your x cannot be equal to 3 and negative 4, okay? Then on a number line, negative 4 is out and 3 is out. So we apply 3 sections like that, okay? So internal rotation must be minus infinity to minus 4 and minus 4 to 3 and 3 to infinity.